Hi all, in this video I'd like to make sure everybody knows what a piecewise function is and understands the notation that will go with a piecewise function. So I'm going to do two. I'm going to start off with one that's made out of two pieces. So this one is going to be called f of x, and f of x is equal to the absolute value of x if your x is less than 2. And it's x minus 2 if your x is greater than or equal to 4. Okay, so hopefully we're getting used to what our basic functions look like. So what I have here is the basic absolute value function. So in my head, I'm picturing a v that has its corner right at the origin, slope of 1 on the right side of the y-axis and a -1 on the left side. If you have a pencil, you can even lightly draw that in just to give yourself a starting place. But what this notation is telling me is that my function will be the absolute value function only when my x values are less than 2. So I need to picture that v graph getting cut off at x equals 2, which also means y equals 2. Since that's a strict inequality, I don't want to include the 0.22. I'll give it an open circle. So that shows that everything right up to 2 is included, but not the 0.22 exactly. Again, x is less than 2, so I want to keep all of the v that's to the left of my open circle. Okay, that's just going to head off forever. So this will hit -2, 2, -3, 3, -4, 4, and so on. So this is just the first part of my function. So again, my function is made up of two pieces. The first piece is an absolute value, and that piece only applies when x values are less than 2. The second piece is y equals x minus 2 if x is greater than or equal to 4. So again, just to get a picture in your head, if you have a pencil, feel free to pencil this in. This is a line. It's got a slope of +1, and it's got a y-intercept of -2. So in my head or with my pencil, I'm picturing a line that starts at 0, -2, goes over 1, up 1, over 1, up 1. So it'll hit 2, 0, and then just keep on going. So again, here, I'll just really lightly show what's going on here. Okay, so this is what I'm picturing. I'm supposed to cut this line off at x equals 4. When x equals 4, this line is hitting y equals 2. So this is 4, 2. And since I have an equal to here, I want to include x equal to 4. I'm going to go ahead and fill that in and make it a closed circle. Other than that, I want only x is greater than 4, so I'm going to keep the right-hand side of this graph. So again, this is just my line with a slope of 1, so it's going to go through 5, 3, 6, 4, and so on. And these two pieces put together make up my function f of x. So just to make sure that you're clear on how these work, either looking at the graph or the equation, we should be able to figure out things like what is f of -3. And this is kind of a two-step process. First, you would check over here. These are domain restrictions for the individual pieces of the function. If I want to plug in a -3, I have to use the first piece of this function because -3 is less than 2. I then take that -3, now that I've decided I'm going to use the top part, and I plug it in, and I get back +3. I should also be able to find f of 4. Ooh, I'm going to go f of 5 because 4 seems boring based on what we've already done. If I want to plug 5 into this function, I first check over here to see which piece of the equation to use. So if x is 5, that is bigger than 4. I can then go over here and use the equation. The equation says that my output will be 2 less than my input. So I'm actually getting 3 from that as well. And we can check and make sure that looks right on our picture. 5, 3 looks good. -3, 3 also looks good. Okay, I'm going to do one more with 3 pieces just so that you've got a couple to look back at and make sure this is making sense. So let's do g of x is equal to x cubed if x is less than or equal to 1, the square root of x if 1 is less than x is less than 4, and 6 minus x if x is greater than or equal to 4. Okay, so I'm kind of changing this up on purpose because I want you to be okay with this. And the last one I wrote the ifs in between. These are supposed to be commas. I don't know if that really looks like a comma. You'll see both, so that's not super picky what goes in the middle. All right, so I'm picturing first an x cubed graph. So that shape is going to be something like this. And I want to only sketch that x cubed shape if my x value is less than or equal to 1. So again, remember, first you figure out your domain restriction, then you plug in. So you're only going to see this graph if you've satisfied this domain restriction. So x cubed goes through 1, 1. We have the equation here, so we can plug the x equals 1 in to figure out our y. And I'm making that a closed circle because I'm using this for all x less than or equal to 1. So 1, 1, I have a closed circle. I then follow my x cubed shape. My x cubed has an inflection point at the origin, and then it heads down through -1, -1, and then it just keeps heading to negative infinity. So this is the leftmost chunk of my graph. The next piece of my graph is a square root function, and I want to see the square root shape from x equals 1 to x equals 4. So again, you can lightly draw in a square root graph if you want. Square root graph starts off kind of steep and then hits 1, 1 and then flattens out quite a bit. So I don't want to see the entire thing. I only want to see the parts of the graph with x values between 1 and 4. So it's going to start at 1, 1 with an open circle. I'll come back to that in just a second. And then it's going to go through 4, 2 with an open circle. And then we're supposed to connect the dots with the part of the square root graph that would live right there. Okay, so 2 things I want to point out. One is if you put an open circle on your graph, that means there is no point there. So when I say that I should start off here with an open circle, it actually immediately gets filled in because there's already a point sitting there from the first piece of the graph. So x cubed going through 1, 1 with a closed circle means there's no reason for me to try to show any kind of open circle here for the second piece of the graph. So you could absolutely fill in open circles by having another point fall inside of them. The other thing I want to point out is sometimes when people draw this, they want to make the square root shape starting with the really steep part up here. So the steep part of the square root graph is at 0, 0, and we are not showing that part. So we get this part over here that's slightly concave down but looks pretty flattened out. You will see in your homework some transformations involved in these piecewise functions, so you might have to move that around, but for this one, that was not what was going on. Okay, the last piece of my function is y equals 6 minus x, and I want to see that only for x is greater than or equal to 4. So this is a line with a slope of -1 and a y-intercept of 6. Oh, I guess I didn't really need to show that. So if my slope is -1, I'm going to hit the x-axis at 6 as well. So it's going to go down 6 over 6, and in fact we can count it out. It would go through 0, 6, it would go through 1, 5, it would go through 2, 4, 3, 3, 4, 2. So it actually goes directly through this point, which is important to follow. And that's where the graph is supposed to start. So when x equals 4, 6 minus x equals 2. So I end up getting to fill in another open circle. This last piece of the graph will fill in that open circle, and then it will continue with its slope of -1 forever. So sometimes the 2 pieces of your graph won't meet. Sometimes pieces of your graph will meet. There can be 2 or 3 or 4 or 5 pieces, however many you need. Again, just make sure that you realize that the way this is written is showing you that there's 3 different pieces to this formula, and over to the right it tells you when to use each piece. Okay, that's it for Piecewise. Thanks for watching.